Hello, and welcome to Team Alpha's Target Increment demo of the Clueless board game for the Foundations of Software Engineering course at Johns Hopkins University for the Spring 2025 semester. In this presentation, my team members and I will provide a thorough walkthrough of our project and its functionality, as well as reflections on what did and did not go well throughout the semester, advice for future students taking this course, and lessons learned that can be applied to real-world projects. Here in this slide, I'd like to provide a brief overview of the group members, their different roles, and an overview of the product being designed this semester. In regards to the group introduction, Ria is the program manager. As the program manager, Ria is responsible for overseeing the project timeline, ensuring collaboration among team members, and maintaining project efficiency. The program manager monitors project milestones and ensures that tasks are completed on time. Josh is the lead architect. As the lead architect, Josh is responsible for designing the general system architecture. The lead architect coordinates with the other developers to ensure that the team understands the general architecture and follows its structure. Hyunjin is the lead tester. As the lead tester, Hyunjin is responsible for ensuring the game functions correctly by thoroughly testing inputs, outputs, and interactions between subsystems. The tester will verify that each system processes given data correctly and produces the expected results. The tester will also identify and test edge cases, uncommon or extreme scenarios, in the program. Paul is the lead programmer. As the lead programmer, Paul is responsible for overseeing the development of the game's core systems, ensuring performance, scalability, and maintainability. The lead programmer guides the other developers, monitors tasks, and ensures coding best practices. Leah is the lead software quality manager. As the lead software quality manager, Leah is responsible for ensuring that the game meets the project standards by reviewing testing strategies, documentation, and code implementation. In regards to the actual product, the product this team is creating is a simplified version of the popular board game Clue. While this version of the game has the same 9 rooms, 6 weapons, and 6 characters as the original game, the main difference is in navigating the game board. The Clueless game is divided into 3 major subsystems. The first is game logic, how the game operates and performs its required functionality. The second is network, how information is transferred between the game server and the players of the game. The third is database, how the data regarding each individual player as well as the game itself is stored. Further information regarding these subsystems as well as how they interact with one another are described in future slides.
Hello, my name is Joshua Delosa, and I will be talking about the relationships between the 3 major subsystems. Our 3 major identified subsystems are the game logic, network, and database. All 3 subsystems rely heavily on each other, which is why they are all necessary to run the game properly. If one of the subsystems is missing from the program, then the game cannot function properly. The game logic is a subsystem that handles the main functionality of the game. It works with the network subsystem to provide the user with the proper interfaces and logic to play the game. The game logic is the main structure of the game that allows the player to actually play, but the game cannot function without a way to store data or communicate between the server and client. The network subsystem is comprised of the client and server. It takes the inputs from the user and verifies that the inputs are correct based on the game logic and current game state. It then updates the game state by updating the database. The network is the main messaging system that allows for proper verification of user inputs and updates the database. The database is in charge of the current game state. It stores all of the user and game information. The database will send the network the current game state based on the user's inputs and then update the game state as the game continues. Without the database, the network cannot provide the game state or verify that the user is making valid inputs for the game. These relationships between the 3 major subsystems show why the game cannot function properly unless all 3 are properly implemented.
Hello, I am Paul Bogner, and I'll discuss our subsystem communication setup. First, we have our Redis server. Redis is used as our message broker to handle real-time communications for the WebSocket connections. It helps synchronize the game state across all players' clients in real time. Second, we have Daphne, our ASGI server for the HTTP and WebSocket protocols. Daphne is an asynchronous server that allows for the real-time nature of the game, especially during players' movements or updates. Last, we have our Python Django server. Django serves as the main application server, handling the HTTP requests for players' logins, game state retrieval, and other general HTTP routes like the game's main page and login or setup functionalities. Now that we know what applications we are using for our subsystems, where can we find them? Our game logic subsystem can be found within Django, responsible for core gameplay mechanics. Our network subsystem can be found within all three applications, with the client being handled by Django through HTML and JavaScript for a user-friendly interface, while the server is handled by all three applications, creating real-time communications, handling incoming requests, processing game logic, and communicates with both the client and the database. And our database subsystem is contained within Django, managing both the game data and its persistence through models and migration. So how do our subsystems communicate with each other? We have game logic and network communication to send game updates to clients and receive player input. There is network to database communication for retrieving and storing game data based on player actions and the current game state. And last, there is database to game logic communication to determine truth for initializing the game and any actions taken. Here we have an example of a player's movement. Step 1, they have selected the space they want to move to on their client. Step 2, the location selected must be verified by the game logic as a valid move. Step 3, if the move is valid, the game logic sends the player's new location to the database to be updated. Step 4, the database confirms that the game state has been updated. The network then broadcasts the new game state to all connected clients.
There are several things that worked well for our group. Using GitHub as a repository for version control was very helpful. It allows us to coordinate developing our code together, let us view each other's commits, and track major changes. If there were any merges that caused problems, we were able to easily revert back to previous commits and troubleshoot the problem. Using Django for developing the game also worked well. Django's built-in features, such as views for handling user interactions, models for managing and querying the database, and its structured approach to application organization greatly contribute to efficient and maintainable development. Microsoft Teams was very useful for coordination and documentation control. Our team had to coordinate with each other over 4 different time zones. The ability to share calendars and view each other's availability greatly facilitated scheduling meetings and collaborative development sessions. By knowing when each member was available, we were able to efficiently coordinate programming tasks and keep the project on track. Teams also allowed us to work on documentation together very easily. Being able to work on documents in parallel and in real time together greatly increased the efficiency of completing documentation. Dividing up tasks early and efficiently also helped with development. With tasks divided, team members could work simultaneously on different components, speeding up overall development. By planning the division of work up front, we avoided delays caused by dependency conflicts or waiting on others.
Looking back on the semester, there were some project aspects that did not work as well as the team would have liked. One such aspect was having weekly team meetings on Fridays. As all of the project deadlines throughout the semester were on Mondays, having the weekly meetings on Fridays left less time to complete the project deliverables. Another detail that was difficult to manage was coordinating team meeting times across multiple time zones. Since group members were located in different time zones across both the US and globally, it was a bit of a challenge to find a time when everyone was available to discuss project work. One more aspect specific to the project itself was the team's difficulty with coordinating how to merge GitHub branches. When team members worked on different sections of the project that were interdependent, merging a GitHub pull request from one team member resulted in causing the code of another team member to not function as intended. These conflicting pull requests resulted in hours of time spent debugging the conflicts and took away from time spent directly working on project code.
Our team has 6 points of advice for future students. 1. Plan early. Beginning the project with a clear understanding of requirements, goals, and responsibilities. Early planning helps prevent last-minute scrambling and sets a strong foundation for execution. 2. Coordinate often. Frequent communication, both formal and informal, keeps everyone aligned, uncovers blockers early, and ensures that tasks are progressing as expected. 3. Start working on project deliverables early. Waiting until the last minute increases stress and risks missed deadlines. Starting early allows time for review, iteration, and polishing the final output. 4. Having weekly team meetings. Regular meetings provide structure, ensure accountability, and give team members the opportunity to sync on progress, adjust priorities, and ask questions. 5. Allowing time to record demo videos. Don't leave demo recordings till the last day. Set aside a few days to rehearse, fix bugs, and produce a clean, well-explained presentation of the project. 6. Coordinate GitHub merging strategy in advance. To avoid conflicts and delays, agree early on how the team will handle branching, pull requests, reviews, and merges. Our key lessons learned, which are applicable for real projects, would be that strategic branching will help teams manage code changes efficiently by organizing work into isolated branches. With a good branching strategy, developers can avoid conflicts and integrate features smoothly. Documenting errors during the build process makes it easier to identify root causes and share solutions with the team. Clear documentation also speeds up debugging and prevents repeated issues. By keeping up the GitHub repository, this ensures that all team members are working with the latest code. An up-to-date GitHub repo also keeps the CI/CD pipeline functioning properly. Code should be reviewed regularly to catch issues early and promote consistent standards. Feedback loops during reviews help improve code quality and encourage collaboration. By using feature-based script separation, each functionality allows to be developed and tested independently. This reduces merge conflicts and makes the code base easier to manage. Debugging flags tied to specific methods or features make it easier to toggle logs on or off. This targeted logging improves visibility when keeping the output clean. Additionally, modular design encourages low coupling and high cohesion, making the system easier to scale and maintain. A modular structure also reduces time spent debugging and simplifies collaboration. By designing the DB schema early, this helps avoid major challenges later on and changes and ensures that the application logic aligns with the database structure. Early schema planning saves time and reduces technical debt.
Hello, stakeholders. I'm Hyunjin Kim. Joshua and I will be representing the demo video and demonstrating how it meets the requirements of the Clueless board game. All of our teammates have been signed up on the system. I created an access point using ngrok to support multiple players logging in from different devices and browsers, enabling them to join the same game from anywhere in the world. I implemented cookie isolation to prevent session overrides, ensuring that a player's data isn't overwritten by another player's data when the page is reloaded. When a player logs in with an incorrect password, the system displays an error message. The server logic randomly assigns unique characters to players when they log into the game. Now, all of our teammates have joined the game. As a dream feature, I implemented a chat function that allows players to coordinate and decide when to start the game. When a player joins the game, a message is automatically broadcast to everyone. They can also start chatting instantly. No need to reload. As you can see in Hyunjin's message, she joined the game using a MacBook and Safari browser, while Paul joined using a MacBook and Firefox browser. Leah joined using an iPad and Safari. Joshua joined using Windows and the Edge browser, and our Team Alpha joined using Windows and the Chrome. Ria joined using an iPhone and the Safari browser. As a dream feature, we implemented light-dark mode for user convenience, ensuring consistent styling across the entire game interface. My messages are displayed on the right, while others' messages appear on the left, accompanied by their user profile images. In the lobby, a case file is generated with a suspect, room, and weapon, and players are assigned cards through the server's game logic. Once more than 3 players have joined the game, the host will be Mrs. Scarlet if that character is assigned. If Mrs. Scarlet is unavailable due to random character assignment, the first player to join the game will be able to start the game. When the host clicks Start Game button, all players are automatically redirected to the game page. Since only 6 players can join the game, player 7 cannot join the game since it's already full. The client receives an error message.
This is a showcase of the suggestion feature and how they meet the requirements of the Clueless board game. So first, a suggestion can only be made on a player's turn. It's currently my turn. I'm going to make a suggestion to Paul. The suggestion is submitted, but because it's not his turn, the suggestion does not go through. Next is that a character can only make a suggestion when they're in a room. So I'm currently Miss Scarlet. I'm going to make a suggestion in the hallway. And see, the suggestion goes through, but because I'm not in a room, nothing is disproved. Now I'm going to move to a room to make a suggestion. As we can see, when I make a suggestion, only a suspect and weapon are available for me to make that suggestion. Before I make a suggestion, I'm going to look at Paul's hand to see what can be disproved for a suggestion. So I see Candlestick and Mrs. Peacock. So, Mrs. Peacock and Candlestick. I'll submit the suggestion. So, as we can see, several things happened. The suggestion is broadcasted. Character disproves the suggestion can be broadcasted. And as we see that Paul has multiple cards for us to disprove, I'm going to pick the Candlestick. So, if player has multiple cards for suggestion, they can pick which one to disprove. And when the suggestion is made, the game goes through each player to determine if anyone else has that. But since Paul had both of the suggestions, we only went through him. I've now eliminated Paul to show that an inactive character can still be moved through a suggestion. So, as you can see, his character was moved even though he's been eliminated from the game. Finally, I'll show that an eliminated character can still disprove a suggestion even when they're no longer active in the game. Okay, as you can see, he has the option to disprove the suggestion even though he's been eliminated.
Players can make an accusation at any time during their turn. Paul make an incorrect accusation immediately after a player enters the game. If an accusation is incorrect, the system privately notifies the accusing player with an alert message. Your accusation was incorrect. You are no longer able to move or make accusations. but you remain a suspect. Then the system broadcasts to all players, Paul has been eliminated due to an incorrect accusation. Player actions are broadcasted with a pop-up displayed at the top left, remaining visible for 5 seconds. Inactive players cannot make accusations. Only the character whose turn it is can make an accusation. In addition, players can move and then make an accusation if it's their turn. The system marks the player as eliminated by disabling all game interactions, such as the player cannot no longer move, their turn is automatically skipped, and the end turn button is disabled. They are no longer eligible to win and cannot make accusations, as the accusations button is disabled. They cannot make suggestions, as the suggestions button is disabled. When only one player remains, because all other players have been eliminated due to incorrect accusations, that player continues taking turns alone, ensuring the game reaches completion. If all players make incorrect accusations, the system disables the accusation buttons for all players, broadcasts the game ending in a tie, and shows a distinct notification style when the game ends. If an accusation is correct, the system broadcasts a message announcing the character who made the correct accusation. Disables the accusation button for all players. Notifies everyone that the game has ended with the correct solution and the winner. Uses a distinct notification style to indicate the end of the game. Players can view the game history by clicking the Game History button. Thank you for your time and attention to Team Alpha's Target Increment demo presentation.